Okay guys, welcome to part 3. So this is the final rule you need to know, and this is always the most difficult one to remember and the most difficult one to use, okay? The rule is called alternate segment theory. So when you give your reason, you just need to say that, okay? And what we're doing here is we're looking for a cyclic triangle. So this is a cyclic triangle, it fits inside the circle, all 3 points on the circumference, and a tangent. And they are meeting at the circumference there. Now, if that is the case, the angle between the tangent on the right-hand side, okay, and the triangle, so this angle here that I'm drawing, is going to be equal to the angle in the triangle to the left-hand side. And it is equally true that this angle here, so the angle between the tangent and the triangle to the left-hand side, is equal to the angle in the triangle to the right-hand side. So those two blue angles are equal as well. That is called alternate segment theory. So you're looking for a triangle that fits inside a circle, meeting a radius at a point on the circumference. Okay? Here is a question for you to do. See if you can work out A, B, and C. Okay? Right, now, A, I can straight away see must be 55 degrees because I have a tangent and I have a triangle meeting, a cyclic triangle that is, meeting that tangent at a point on the circumference. So that means this angle here is the same as this angle here. So it must be 55 degrees. What is angle B? Okay, we're combining lots and lots of rules here. Notice this is a diameter. So this triangle has a base as a diameter, so it's a semicircle. So this is a right angle. Okay, so B must be equal to 180 minus 90 minus 55, which is 35 degrees. So B is equal to 35 degrees. Okay, right, what is angle C? Well, angle C must be, again, if we look here, I've got a triangle, different triangle this time, but still a cyclic triangle, meeting the tangent at the radius, at the circumference. And so this angle must be the same as this angle. So C is 13 degrees. And again, the reason is alternate segment theory. I'm not going to write them down, but you need to. Okay? Alternate segment theory. Right, now, here are 2 questions that sort of bring quite a few of these topics together into one. So, stop your video and see what you can come up with. Okay, so what does x equal? X equals 122 degrees because angle at center is twice angle at circumference. Okay, you'll notice that what we had is an arrow, one of those arrows, okay, with the points at the center and at the circumference. Okay, so what else do we know? We need to find y. Here's an interesting way of doing it. There might be other ways of doing this, but since I know that x is 122 degrees, this triangle is isosceles because these are both the radii. So let's call this angle A, then for this is also angle A. 2A plus 122 equals 180. 2A is equal to 58, so A is 29. So this angle here is 29 degrees. That means this entire angle is 29 plus 35, which is 64. So this angle here is 64, which means that y is also 64 degrees, because we've got alternate segment theory coming into play here. Here is a triangle meeting the circumference and the tangent are all at the same point. Okay, so that angle is the same as that angle. Okay, again, you'd need to list out all the reasons that you've used there. I'm not going to do that because otherwise the video will go on forever. Okay, let's just get rid of that. Okay, what about the second one? Again, we've got to find x and y. So let's have a look. First things first, let's just write in everything I think I can know. I think this one's got to be 19 because angles from the same chord are equal. I'm not sure that is that particularly helpful, but I'll tell you what is helpful. This angle here must be 68 degrees because here we have a cyclic quadrilateral, okay, which means this is also 68 degrees. So you can go about finding as many angles as you possibly can. And this angle I can know because the sum of interior angles of a triangle add to 180 degrees. So 180 minus 68 minus 19, use a calculator. 180 minus 68 minus 19 equals 93. So this angle is 93 degrees. So now I can see x is equal to 87 degrees because angles on a straight line are equal to 180. Now it'd be very easy to get this wrong because it looks like what we have here is an arrow. But that is definitely not an arrow because this point here is not on the circumference of the circle. So that's not an arrow. So we can't use that. We've got to try and find a different way of finding y. What we can do is we can find an arrow here. Here's an arrow. And that is good because that's the center and the edge. So we know it's going to be double to 68 degrees. So y is equal to 2 lots of 68, which is 136 degrees. There may have been other ways to get to the same answer. It doesn't matter how you do it, as long as you write down the reasons and show how you came up with your answer. Okay, final thing, I'm not going to give you the answer to this. I'm going to give you the answer to this live. What an IGCSE exam will do, because they like to make things difficult and really test your intelligence, they like to combine topics. So this is a question that does require circle theorems, but it also requires another area of maths that we have learnt before. Okay? I'm not going to tell you what that area of maths is. I want to see if you can work it out yourself. But essentially, what you've got to do is find out what the size of this angle is. And bear in mind that you are not given any angles yet. You haven't been given any. But it is still possible to work out what this angle size is. Actually, this question brings in 3 or 4 different areas of maths, all in one question. Okay, and that is what the GCSE is going to do. So again, if you can work out the answer to this question, submit a picture in private message on Teams, and let's see how many of you can get it right. 6 of you got the last challenge correct. Let's see if we can do better and have more of you get this right. If you want to work together and submit a collaborative solution, then that's fine by me as well.